See Lindelof videos, AP Calculus, ti-nspire CAS particle motion problem. I want to kind of warn you before we start that this is how I would answer an AP Calculus free response question on particle motion, which have showed up every year for the last 15 years. However, they're not going to ask it exactly the same way, so I just want to show you how I'd set this problem up. It says a particle travels on a number line with position given by s of t is equal to t sine t on the interval 0 to 2 pi inclusive. This is what they're not going to ask you. They're not going to ask you to find this velocity and acceleration function. However, showing them that you have them will be really, really helpful. So the first thing I'm going to do is I'm going to go to my calculator, and I'm going to start saving this function. I'm going to put in t times sine t as in open parentheses t, control store, and I'm going to actually call that s of t because that's what they do on the, so s of t. And I'm going to hit enter here. Just take a quick peek to make sure that I typed it in the way I was supposed to, because it's pretty anticlimactic. It just says done. But then we can start to do our math here, and this is what I'd like to do. I'm going to hit the menu button. I'm going to choose calculus. The first choice is derivative, so I'm going to choose derivative. Important here because I used the variable t so that I asked for my derivative in terms of t. So I want ddt of s of t, so s of t. Enter. So I guess the first thing I do is I would write that down. So let me just switch real quick. I would actually write that down. And this is the way I would write it down. I would say that s prime at t is equal to v of t, which is equal to t times cosine t plus sine t plus sine of t. So there is my velocity function, and I'd do that, velocity. The next thing I'd do is I'd go back to my calculator. I'm making sure that I'm giving good notes to my reader so he or she can give me my points, frankly. I'm going to go to here. Then what I'm going to do is this. I'm going to take my cursor here. I'm just going to push up, and I'm going to hit enter. And by doing that, I just copied this, and then I'm going to hit control store. And remember, we named that v of t for velocity, so I'm going to go ahead and save that as v of t for velocity, and hit enter. I'm trying to save myself some steps here. They ask us for the acceleration function, and we know that acceleration is the first derivative of velocity. Same thing we did last time. I'm going to hit menu. Fourth choice is calculus. I'm going to take that derivative. Remember, our derivative in this case is in terms of t. I'm going to jump over to here, right? And I'm going to type in v of t because I want the first derivative of velocity, so v of t. And I'm going to hit enter. Enter, and there's that. So we have that down. Of course, I'm going to go right back to my paper, and I'm going to copy that down because knowing it is not enough. Maybe what I'll do is I'll put acceleration down here and say that v prime at t is the same as a of t, and that a of t is equal to 2 cosine t, right? 2 cosine t minus t sine t, I think, isn't it? T sine t. And that's how I'm going to leave that. Here, as we continue to answer the question, it says here, for what values of the particle is the particle at rest? Well, I know this. Rest when v of t is equal to 0. Right? And remember, we're on 0 to 2 pi is an interval, not a point. It's an interval, isn't it? So I'm just going to show them this just in case I screw up my arithmetic. So I'm going to show them that, hey, I know that when velocity is 0, then my particle is at rest. And then I'm going to go back to my calculator. And this is actually really easy. I'm going to type it in. I'm going to say solve, S-O-L-V-E, S-O-L-V-E, solve. And then I'm going to put in that velocity function, velocity at time is equal to 0. What's important here is that you put in here comma t. Your calculator is not as smart as it seems. It needs to know in terms of what. Then I'm going to hit this answer, and it comes out really crappy looking, but don't panic. Don't panic. It's going to be cool. So there it is. You're like, what the hell is that mess? Well, I look, I'm like, these are not good answers, because remember that the interval that we're on is 0 to 2 pi. So I'm just going to paddle through here, and I'm going to look. I'm going to keep looking here. That's not it. Or now it's starting to show up, isn't it? So here are the values that I'm looking for. Right here. So t is 0. That's on our interval. T is 2.02876. T is this amount. This is still less than 2 pi. Remember, 2 pi is about 6.28. And then I'm like, okay, 51 is definitely outside that interval. So we have three values. T is 0 is one. T is 2.028 blah 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 is another one, and T is 4.913 is the last one. The rest of them are outside of our interval. So then what I'm going to do is this. I'm going to write that first. I guess I'm going to write that down, right? And we write down those values that we got, and the values that we got were these. So T equals 4.913. T equals 0. I put them out of order a little bit. Sorry. T equals 2.029. I'm using a little bit of rounding here, which is fine. One thing that I wouldn't do is I would copy those numbers as well as much as possible, when possible. So we have these values. So that's that answer. I think that's a good answer. It says draw a path and calculate the total distance traveled. Well, the way I'm going to do that is this. I went back. I did use my calculator, and I'll show you how I did it if you'd like. But I started off with this. I started off with this number line. I said, okay, I'm on this. I got to get through this interval up here. So this is what I'm pursuing right here. I'm trying to get through this interval. What happens? So at t is 0. So at t equals 0. Our guy is at a stop, and we're at position 0. So at t is 0, position is 0. He stops again at t is 2.09. So I'm going to go out here to t equals 2.29. And the reason I chose to put it on the right is because I already did the position, and the position happened to have turned out to be 1.82. So the guy starts here, right? Initially, he goes right. He goes right to here, right? I'm like, okay. He goes right to here. What I know next is that he stops here and then he goes left. So I'm going to draw this little marker here, and then I'm going to draw the next time that he stops is at 4.913. So t equals 4.913, and that position is, where does he end up? Oh, there it is. His position is negative 4.814. So he goes all the way back to here, doesn't he? And he gets to this point. And then he stops and he goes back. And you're like, well, why does we have to keep track of him going back? Because we need to find out from 0 to 2 pi. And we haven't gotten to 2 pi yet. So I have to go to 2 pi and figure out where he is at 2 pi. And I figured that out using my calculator. And I found out that when t is 2 pi, s is 0 again. So now I have to start counting this stuff up. It says, draw the path. So here's my path, and calculate his total distance. Well, his total distance here is 1.82, isn't it? Sorry, 1.84, isn't it? From 0 to 1.8. Sorry, from 0 to 1.82 is 1.82, right? But remember, now he's at 1.82, and he's traveling all the way back to negative 4.814, and that's a total distance here. This is a total distance of 6.843, right? Because he travels to 1.82 to get this far, and then he travels an additional negative this distance. Remember that distance is not negative, so we take its absolute value. And then he goes from here, and this is position negative 4.814, back to 0, and that's another 4.814. And then you add all of those amounts together, and it's 13 something, right? Total distance equals, right? Total distance equals 13 and whatever that is. And I can do that math if you like, but I'm just showing you how I would do this. Remember that if he's at 1.82 and he travels back to negative 4.814, it's the absolute value from this number to 0 plus the absolute value from 0 to that number. So make sure you're counting everything, right? So I hope this is really helpful. Oh, let me show you really quickly what you can do with a calculator, because I did that. I had those values, and I said, what is S of 0? And S of 0 was 0, so if you look at the chart, I had that. And then the next value that we had where he stopped was 2.029, so I did that, and I said, where is he at S of 2.029? Hit enter, and I got this approximate number. I rounded it up to 1.82. And then lastly, I asked where he was the last time he stops. And the last time he stops is at 4.913, so 4.913. And I hit enter, and then I got that. Remember, I want absolute value here because that's the distance he's going to travel. All right? I hope this was helpful. I hope you're working on these problems. You're going to see these problems. I would say to you in parting that all this cool stuff that you get off your calculator, make sure that it ends up in your work so that your AP reader can give you all of your points. You really, really have to hold their hand to help them to give you all the points that are due to you. I hope the video was helpful. If you have any comments, please make them. And if you haven't already subscribed, please do. Thanks, you guys.